Bonjour à tous et à toutes. Je vous remercie d'être ici.
Good morning, everyone. I'd like to welcome you all for being here today.
Dans un premier temps, nous allons faire la présentation en français.
We'll be making presentations today in French, and the slides will be in English.
Donc le projet Tiger, c'est un projet collaboratif.
The Tiger project is a European collaborative project,
Financé par ce qu'on appelle le programme Interreg France Channel.
and it's financed in the context of the Interreg France Channel England programme.
Se mettent ensemble pour trouver des solutions à une problématique commune.
And its objective is to find common solutions to problems in the programme area.
La mer, en fait, l'énergie hydrolienne. Comment on arrive sur une zone assez large, le sud de l'Angleterre et le nord de la France, à travailler un seul et même sujet en rassemblant les forces.
So it's a large area that brings together French and English partners to deal with tidal energy.
Un projet qui a un budget assez conséquent, puisqu'il y a plus de 45 millions d'euros qui ont été investis dans ce projet-là.
It's a project which has a total budget of 45.4 million euros.
Un projet qui va durer 4
A
ans.
project that lasts 4 years,
Et il va se terminer donc, dans un an.
which closes in just under a year in 2023.
Sur un sujet qui est assez conséquent. Et ça permet aussi en fait, de pouvoir travailler sur des investissements et sur une mise en perspective aussi au-delà de 2023, bien sûr. Les 4 ans de travail, ça permet quand même d'avoir de bons résultats. Et on regroupe en tout 18 partenaires.
So 4 years will provide enough time to bring some project results forwards
La zone Manche-Angleterre, c'est
and create a legacy for tidal energy in the channel for future investments.
18 en tout, avec 6 partenaires qui vont travailler d'avant.
So the 18 partners in the project are situated both in the UK and in the French area indicated on the map.
Des universités qui vont travailler sur la production de nouvelles
6 technology partners, 6 universities, and 2 regional agencies.
territoires avec 2 agences régionales qui vont permettre à un écosystème un peu plus large de se mettre en place et de favoriser aussi l'émergence du marché hydrolien. Le projet Tiger s'est organisé autour de plusieurs activités.
The Tiger project is organised around several activities. The first activity
On va le voir tout à l'heure dans la présentation. Donc chacun va expliquer son niveau de développement. Donc des sites d'essai qui vont mettre en place les solutions, voir ce qui fonctionne.
So the test sites are putting in place solutions to test what works, to see what doesn't work, and share experience with the other sites.
Faire lever des routes technologiques par rapport aux contraintes que l'on va rencontrer. Et enfin, Tiger, c'est aussi travailler sur la réduction du coût. Comment, pour une technologie qui
So looking at sector and technology developments and also cost reductions for the sector.
fait que le coût d'énergie est vraiment une problématique extrêmement importante et qui est un sujet
The
dans lequel on
lowering the cost of energy is the fundamental problem challenge for the tidal energy sector at this point.
d'essai. Et l'idée, c'était de regrouper dans un seul et même projet différents sites d'essai. Il y en a 5 en tout.
So we got 5 test sites throughout the project.
Et comment on pouvait, en déployant et en améliorant ces différents sites, pouvoir faire émerger un marché de l'hydrolien au niveau mondial et avoir une offre européenne au niveau mondial.
So the objective here is to test the tidal energies in these different sites with a view to having achieving commercially available technology in a few years on a global scale.
Présenté par Marlène. Ensuite, on a un troisième site.
Introducing the 3 sites, so we've got the first site from the Morbihan, the second site which is Paimpol Brea, and the final one, of course, coming from the Ras Blanchard in Normandy.
Leur développement par rapport à une offre de déploiement de la technologie hydrolienne sur un marché qui est encore à construire. Et enfin, on va retrouver donc, au niveau anglais un site, le site de Ramsey.
And finally, we've got the UK sites there, the Ramsey Sound site in Wales, and of course the PTEC site in the Isle of Wight as well.
Le projet Tiger, on a donc un travail avec ces sites d'essai sur le développement et l'amélioration de la technologie et des infrastructures. Et on a aussi, c'est important à avoir en tête, un travail donc, des universitaires pour produire de la connaissance et pour avoir des
So whilst the test sites are demonstrating new energies, we've also got the university partners which are developing knowledge around the technology, and much of this information is being shared through our website, as you can see on screen.
En complément en fait, de la production de cette connaissance, l'idée c'est aussi de travailler plutôt sur le terrain, donc avec les sites d'essai qui sont autour de la table, et de voir par rapport à la supply chain qui est l'objet aujourd'hui.
So with the test sites here gathered today, the objective here is to see how the supply chain can anticipate some of the opportunities which will emerge from the sector, and to do this we've created a supply chain engagement process around these three main axes. So today, each of the seats will be able to tell you what they need, what they're waiting, and some of their aspirations for the technologies in the test sites they're working in. You can find the all the previous webinars that we've done on supply chain activity on our website.
Je voulais également, en fait, en complément de l'explication globale du projet Tiger, je voulais vous présenter en fait Monsieur Simon Cheeseman, qui est le coordinateur.
So I've finished my introduction now. I would like at this point to introduce Simon Cheeseman.
So I'm the project sponsor, if you like, and I work for the Offshore Renewable Energy Catapult. The Catapult is a UK-based organisation with the lead renewable innovation centre covering offshore wind, wave and tidal energy. And as Helen said, the project started about 3 years ago. And 3 years ago, we were in a very different world. It was pre-COVID. It was before the horrible situation out in the Ukraine. And now we're in a situation where a lot of companies have declared a climate emergency. In the UK, we've got significant net zero targets for 2050. And we're very acutely aware of the importance of having security of supply of energy. And, we live in communities that are surrounded by water. So we ask ourselves, why haven't we got more tidal energy? We know we can produce tidal turbines. We know we can connect them to the grid. But as Helen said, it's all about the cost of that electricity and driving that cost down. The Catapult is an organisation that works with technology developers to help them to reduce the cost of their energy, help them to commercialise their product. And we've got some pioneers of tidal energy here for you today. They're extremely busy people. They've got devices in and out of the water. They're going to tell you some great stuff about their technology, and I'd encourage you to ask them questions, because that's what they like to talk about, is their technology. So Tiger is a very important project for all of us in terms of sort of securing our future energy system, and tidal can play a very important part in that. And we're absolutely convinced that we can get that cost down, and that tidal will play a very important part in our energy mix in the future.
Merci Simon.
Thank you, Simon.
Ce que je vous propose maintenant, c'est de
What I would suggest now is that we get into the heart of the subject. We'll introduce each of the different test sites. So the first I'd like to introduce is Thomas Archinard from the Morbihan Hydroenergy test site. Morbihan Hydroenergy is a project partner which is looking at installing 2 tidal turbines in the Gulf of Morbihan by the end of 2023. Thank you, Helen. Talk about the project, talk about Sabella, talk about what we're trying to develop in the Morbihan with the 2 turbines, which will be located in the site that you can see on your screen in front of you. The photo is illustrative of how busy this stretch is. Picture is taken during the week of the Gulf Heritage Sailing event. There's lots of activity, there's lots of movements, lots of shipping using this particular strait, which goes. So one of the big challenges we have is obviously bringing together the local stakeholders within this project. Won't stay too long on this slide, but you can see we're situated in the area number 5. We're working a lot on environmental studies with the University of Brittany South, or South University South Brittany. So the objective is to install the turbines in the area that's highlighted there on the slide in front of you. The purpose of these turbines are to test their exploratory potential and see how they perform. So we're looking to install 2 hydro turbines which are experimental in the Gulf during a period of 3 years. The 2 turbines have different designs. We'll continue to be working with the University of Brittany South on the studies, on the impacts on the environment where these hydro turbines are situated. MHE has been constituted with Morbihan Energies and Sabella. It's a joint venture. So the machines will look a little bit like the one you see on the slide in front of you, with a fixed nacelle, a maximum of economic value. So the conversion and the electricity transformers are on board the machine. There's a modular base to the turbine, gravity base to the turbine. No need to actually drill any holes in the seabed. It sits there under its own weight. So the 2 turbines that we'll install at this site will be each 250 kilowatts, 14 meters high. So in relation to our main suppliers, we are in a situation of co-design and co-construction with a number of suppliers who we work with regularly in relation particularly to the principal components of the turbine. These components are heavy, they're constructed as close to the site as we can. All the composite elements of the turbine are constructed in Finistère or even in Morbihan, including the blades, for example. We work with a number of French suppliers, of course. So elements, components like the generators and so on. So we're very keen to work with suppliers, particularly the very experienced in similar sectors. Of course, our machines are very different from those which they may have worked on before, but equally their experience, past experience in those sectors is helpful. So a number of these components are constructed in France.
anglo-saxon.
So the wetmates are produced by a British partner.
Effectivement, l'ensemble de l'embase et des lestes sont peu de plus-value à aller chercher ça ailleurs, donc c'est justement chez les réalisateurs le plus proche possible. J'ai pas prévu de détailler les briques techno qu'on va implémenter dans le cas de Tiger, mais si vous avez des questions, il y a une...
I haven't had the opportunity today to actually go into each of the technical components of this machine, but if you have any questions, please come back to me.
Elle va reposer sur la mise en place d'un outil industriel essentiellement lié à l'assemblage et au testing de la machine sur le polder, sur le port à Brest.
So here you see the 44-hectare site that we're developing for a test bench in the port of Brest on some reclaimed land in the port of Brest. It's a significant investment.
De construire un premier bâtiment avec Brest Métropole à cet endroit-là qui aura une voirie lourde qui permet de déplacer nos turbines sans difficulté et de
The site allows us to test the turbines and transport them to and from the test sites with relative ease.
Il est sorti de terre il y a peu de temps, donc il est prêt. C'est un bâtiment qui fait 1500 mètres carrés.
So we've got a building that's being constructed at the moment, which is 150 square meters.
Des turbines montagneuses. Il y a une grande porte sectionnelle, on peut rentrer la machine et quasiment mettre son base à l'intérieur.
So the machines can actually be put inside the new facilities.
Effectivement, sur le polder, puis poil en face des tentes à Brest. C'est un bâtiment qui a été mis en place via un partage avec la métropole de Brest.
So it's a building that's been put in place and constructed by the Brest authorities, Brest City Council authorities.
Il y a du 3D un petit peu de l'assemblage. Donc notre métier, c'est de concevoir des turbines, de fédérer des partenaires industriels et leur faire comprendre.
The base gives us an opportunity to bring together suppliers, bring together those working on the turbines, and manage the testing of the machines in a safe environment.
On est en train de mettre en place donc une infrastructure qui va nous permettre de roder nos machines avant de les mettre à l'eau.
So we're looking to put in place a facility so that we can test the turbine thoroughly before it's put into the water. The test bench you see in front of you can actually simulate the conditions that we will expect in the Morbihan. So back to the issues of today, the opportunities. So a number of the procurements in relation to the machines themselves have already been completed. But we have a number of real opportunities, particularly around things like the supply of cables. We'll be looking to purchase 2 times 5 kilometers of cable to connect the machines to the land. We will be launching a call for proposals, call for tender in the coming months for this. So some of the supply chain opportunities also concern the waterborne support for the turbine deployment.
La distance entre les deux pointes, c'est 400 mètres. Il y aura du monde qui assistera aux opérations. Donc il y a un enjeu fort sur la mise en œuvre d'une opération totalement dérisquée sur le site. Donc les colis sont beaucoup plus légers que notre machine à récent. On a des colis qui ne dépasseront pas les 50 tonnes.
So the weight of the machines, individual machines, it doesn't go beyond 50 tons, which is a lot lighter than our other turbines that we've deployed in the Ushant area.
Les infrastructures de conversion d'énergie, elles sont dans la machine, mais on a un poste de réinjection à tâche. La ligne Enedis est en 20 kg, donc on convertit de 6 à 20. Et l'idée, c'est de mettre en place une petite simulation là, sur le slide, donc 2 conteneurs pour accueillir les organes de commande et on va dire de sécurisation de la réserve.
So on shore we have a number of requirements as well. We need to construct the services for being able to receive the energy from the turbines and a substation for connecting it to the grid, local grid. There's also 130 meters of road and infrastructure works to be completed once for the cables to be put below the street level and repairs to the surfaces.
On va passer à la présentation suivante.
So we're going to go on to the next presentation from Mr. Drew Blaxland, representing Normandy Hydrolian here today, which brings together CMEC Atlantis and Normandy Hydrolian, who talk about the supply chain on their territory.
Thank you for coming today. I'm going to take you through our project. It's a nice thing about tidal turbines these days. They're a lot more similar to each other. Very similar to the Sabellas, except we're down in the Normandy region. We've been building turbines in one form or another nearly 20 years, hence why I'm now grey. I wasn't grey when I started doing this. And we've done them in Australia, Northern Ireland, the UK, obviously. Scotland has the world's largest small array there in terms of 6 megawatts. Recently did a turbine in Japan and one under license in China. So we're getting around the world with our pilot turbines, but obviously getting to volume, getting the cost of energy down is the key here. Next slide, please. So a little bit about the project. Normandy Hydrolians will develop one of the first arrays in the multi-turbine array in the Rasbon shunt. 4 turbines. The architecture, as you can see on the slide there, is 4 turbines connected to a subsea hub. We're 7 kilometres offshore. The major site that we have in Scotland, we're only 2 kilometres offshore. And that currently runs 4 turbines back to the beach with 4 individual cables. So one of the great ways of reducing the cost overall is to reduce the amount of cabling. It reduces construction costs, it reduces capital investment. And to do that, we need a subsea hub, and that is largely, in nice simple terms, a junction box subsea that allows those 4 turbines to be connected up with wet main systems that are about 200 to 300 metres apart from the subsea hub, worst case, and back to the beach with 1 cable. We've already installed a hub in Scotland as a trial to make sure it was installable, to make sure it's connectable, and that's all worked well. And our turbine there is currently kicking out 400 odd megawatt hours a month through that hub. So very happy with that so far. We're going from gravity-based foundations, which is what we use now, similar to Sabella at the Magen site. In Normandy, we're going to go to monopile foundations, so we'll pin piles to the ground. Gravity-based we've used extensively since 2010. We've been installing turbines since 2010 in the North Sea, and the gravity-based foundations, I think, are the right choice when you're at smaller volumes. Once you get to higher volume, they're quite material cost intensive. So there are options there to get that cost down. And the architecture you see on the board there was already consented in this area. So there's an existing consent that we've taken over and getting varied to take these larger turbines. These turbines were originally consented at 1.4 megawatts. We are now getting the consent variation for 3 megawatt turbines. So a little bit like wind, one of the key indicators in getting costs down is getting rotor size and rating up, just the way wind is. The restriction in tide, of course, is the water's only so deep, so the sky's not the limit. So these will be 3 megawatts, 24 metre rotor diameter, as opposed to the first 1.5 megawatt turbines we did in Scotland, which were 1.5 meg, obviously, and 18 metres diameter. The consenting approach, the feed, that's the front end engineering design, is largely complete. complete. We'll have that completed by, at the worst case, Q1 next year. It's slightly ahead of schedule at the moment. And construction's targeted to start within 12 months of that. I'd like it to start earlier. I'd like it to start next year, but as a realistic sort of safety buffer, Q1 2024. Next slide, please. Important to us is our little array will, 12 megawatts is still small by wind standards, will showcase a way forward for these commercial arrays. It will validate or not the reduced levelized cost of energy, and will certainly enable France, which is really important, to deliver on Europe's mandate, which is a gigawatt of marine energy by 2030, which is a big target to aim for, and I believe it's achievable. It also facilitated an industry strategy that will see up to 100% of tidal products being able to be provided by the local supply chain. Most of my presentation is going to be about how we achieve that. And it opens up a $3.5 billion construction market. So that one gigawatt is $3.5 billion. This is proper numbers now. This is tidal moving from being trial sites, a couple of turbines moving to volume, which I believe we can achieve. And important, and that's one of the real benefits of the Tiger program, is we're all sharing information, we're all learning from each other, which is we would expect to continue to happen through this pilot. Next slide, please. So how do we enable the local supply chain? The business model utilises unique tidal array knowledge and experience to enable local ownership. It's really important. It doesn't matter what country you're in, it's very important. Based on some simple facts, these are 150-ton turbines. And the foundations, gravity-based foundations, anything up to 1,500 ton. Monopiles are big. You want that built as local as you can, particularly with the state of the world's logistics at the moment. So enabling that supply chain, and effectively, if you look at us now, which is the red section, we do pilot projects. We own those, majority own, which we're doing with Normandy or Berlin. And our initial turbine systems are designed and managed by us, with up to about 65% local supply chain into those first 4 turbines. When you move to the blue section, which is volume, we tend to get out of projects. So we're a project partner to enable our technology, and we'll sell that down to local energy companies and continue to provide development support to that. The volume turbines, it's no different to where wind was back in the 1980s. Just because you have fantastic technology doesn't mean you have a balance sheet to warrant it. You need a balance sheet OEM to back these in volume. And that's again where our franchise or licensing agreement comes into place. And that we would expect that OEM to then use up to 100% local supply. Next slide, please. So how do we do that? How do we localize it? For us, and I've been working with these turbines now for 15 years, absolute key, 2 key things that I said as a mandate to the designers. One, it must be modular, so that the modules can be provided from anywhere in the world, a broader supply chain. It also keeps the weight down. Each of the modules is no more than, call it 30 ton. And it also must be handleable offshore. And a lot of our competitors get this wrong here, and we're actually helping Hammerfest with that major now. Making the turbines so they're simple and easy to get off the deck of the ship. I'm talking obviously subsea turbines as opposed to floating ones. And into the water and out of the water in relatively quick time is where you save a lot of money. And the AR1500, you can see in the photos there, it's the same level in air as it is in water within a degree. That sounds reasonably simple, but it's actually not that simple to achieve. By doing that, it means that you're through the water column and we install that turbine in no more than 20 minutes, and we can recover it quickly. So that means you can only work offshore in tides when the slack tides are there. So you've only got 30 to 90 minutes to work before the tides run too fast again. So time is the essence, and utilising those tides. You can see in the table there that the turbine modules are 8 simple modules, and the rest of the system is there. We have our converters on shore. That's not to say we wouldn't change that in the future, and I'm very keen to see how you go with that. But at the moment, we have our converters on shore, and we're using fairly standard ABB GE type converters. But the turbine themselves is the tricky bit, because that's the bespoke bits of kit that we need for the turbine. And getting that built locally is absolutely fundamental. Next slide, please. We ran an EOI process last year, expression of interest for the technology. That went really well. We've got about 70% at the moment of local supply chain interested, and we'll be moving to a formal tendering process later this year, worst case early next year, as we move from front-end engineering design to detailed design. And if you need any more information or interest on that, please email us. See me after the presentation. We're also opening an office in Normandy. Haven't decided yet between Cherbourg and Caen. It's to be decided. And currently recruiting for a project director. So if anyone's interested in that, come and see me. Just a final couple of slides, really, just to take you through a bit of supply chain stuff. The blades currently carbon fibre. We've used fiberglass without carbon fibre. We're now using carbon fibre. I think we're actually quite happy with our fiberglass blades. It's just pretty safe at the moment. No one wants broken blades. And we see some cost savings coming in the future of blades. We would like to see that set up as a facility in the same region as we're doing the turbine assembly. It's labour intensive and great for local employment. And that's part of our plans, that we would do that, potentially get volume under a joint venture with the local fiberglass business. Major steelwork, we've got the nacelle, the gentleman inside the nacelle there, that's about 20 tonne. We've got the main shaft, that's another 16 tonne. You've got the stab, which connects the turbine to the foundation, and it just sits there under gravity, under its own weight. These are all big, meaty bits of kit, around 20 tonne each, 11 to 20 tonne, and definitely, preferably, be done as close as possible to the site. Next slide, please. Lots of minor assembly and minor works, which is fundamentally can be done locally, and we're already talking to some people for that. The nice thing with our turbines is there's nothing particularly clever in the assembly. It's what I like to sometimes refer to as the IKEA of the tidal turbine. It's not that hard. You get an Allen key, you put it together. You can do it. We can assemble a turbine in about 3 weeks, and certainly when you get to volume, that will improve it. Next slide, please. Specialist components, each of those are in the order of 30 tonne. That's your gearbox generator. Combined, we've got a hybrid there, so it's a bearingless generator. And you've got the pitch and the yaw system. We've built turbines without pitches and yaws. The one in Japan at the moment is just a fixed pitch. And it's, again, a bespoke application depending on what you're trying to achieve. Certainly in the raised bond shard, the same as major, the pitch and yaw, of course, the strength of the currents. Next slide, please. We have electrical, which is fairly standard. The one thing that I'll say about electrical is quality is the utmost importance. The supply chain needs to understand that these turbines go underwater and are supposed to stay there for 5 years. You'll never get an electrical contract to take the liability if the turbine breaks down to go and get it out. So having an absolutely bulletproof quality system around the small parts of the turbine is where most of the problems happen, not around the big parts these days. So that's key to part of our forward-looking industrialisation of volume. And the last couple of slides, offshore construction is still a major part of this. The people with floating turbines often say this is the Achilles heel of subsea turbines. I disagree. We've been doing this a lot. When you get to volume, you should be able to install or recover a turbine for less than 50,000. That's not a lot of money in the scheme of things. It's currently costing more like 200,000 or 300,000 for a quick recovery. We've been doing this since 2010. The vessel market we use is the same as everyone uses in this room, which is the offshore DP vessel market, the spot market. It's expensive again now, just as it was in 2010, and we've been through the good times when it was cheap. And the following, we expect to actually, following the Raspberry Sharp pilot, to build our own vessel. That's an important part of our volume plans. And the final slide, which is a little bit similar to Thomas, we've put a lot of time and effort already into choosing sites in Cherbourg, looking at how you get volume manufacturing. We've got a concept design for 100 turbine per year facility, which is one of the pictures from. Thank you very much.
Donc ça a apporté un grand lot de données et d'apprentissage qui nous permettent de nous tourner vers la prochaine étape, qui est une ferme pilote qu'on va réaliser au Raz Blanchard, donc ça après. Et tous ces apprentissages ont permis d'améliorer l'hydrolienne, donc de passer à la nouvelle génération.
So we're talking about the Raz Blanchard site and the opportunities that the HydroQuest pilot project has given to our development of the next generation turbine. We've managed to increase the performance of the turbine element or component by 50% in terms of yield. It's lighter, it's more powerful, it's easier to manufacture. We've lowered the cost. So the project's called FlowWatt at the Raz Blanchard pilot farm. So the construction will start in 2024, an installation which will installation take place during 2025 with a view to operation starting in 2026. At this particular stage, so this is an intermediary step we're at the moment before we start launching a series of larger scale calls for tenders.
Les trois grands gains se feront autour de l'effet d'échelle, autour de l'augmentation de la taille des turbines, ce qui permet de réduire les coûts.
So we're hoping to increase the size of the machines to create an economy of scale and reduce the cost of energy produced, with the objective of having 1 gigawatt of production by 2035. This is a slide just to explain how we are organised contractually in terms of the way we manage the project. CARE is a company which is supporting us, allowing us as HydroQuest to focus on what we're our core business. HydroQuest will carry out the construction of the turbine.
Sur la partie raccordement export, on travaille à réaliser un EPCiste complet et là on travaille avec des EPCistes sur ce sujet-là. Donc là, le choix il est en cours.
So we're looking currently at a selection of a supplier and also an installation contractor at this particular point. In terms of the turbine, we've got a turbine with a gravity base. So we've got the blades, we've got the structure. We've got everything that's conversion of an export connection, generator on the foundation.
Là, actuellement, on a fait un choix de fournisseur stratégique sur les parties clés de la turbine.
So the key parts of the turbine, we have already selected a supplier, which is CMN. So just a partner that's been with us for a long period of time, helping with the turbine superstructure, the blades, and of course the assembly.
la partie, toutes les autres parties, donc partie génératrice, multiplicateur, porte-palier, et puis voilà, toutes ces pièces-là, on a des appels d'offres, soit en cours, soit à venir.
So there's some calls for tender that are to be published or are ongoing in relation to the elements you see in the middle: generators, gearbox, bearings, turbine export connection, electrical shelters.
Sur la partie fondation,
in relation to the foundation,
sur la partie l'est, c'est pareil, on a un partenariat avec la société FMGC. Et sur la partie structure de la fondation,
so the ballast units, we have FMGC, but with regards to the foundation, we're looking for a supplier, expecting the foundation to be in the region of 230 tons.
Donc pour vous illustrer où on en est sur la partie turbine fondation,
to show you where we are in relation to the turbine construction.
Ici sur la carte, avec les volumes de valeur ajoutée associés. Donc on a 60% de la valeur qui est déjà affectée, déjà choisie.
So 60% of the overall value has already been allocated to the following suppliers.
Sur comment ensuite on s'organise au niveau de l'assemblage et de la fabrication. Donc la fabrication de la turbine, enfin, des éléments séparés, elle se fait principalement au chantier CMN.
So the individual turbine elements are being constructed in the CMN facility in Cherbourg.
Et l'assemblage de tous les éléments qui se fait sur le port. Donc tous les éléments sont qualifiés, testés séparément.
So all these elements will be assembled on the port in Cherbourg.
L'assemblage final, l'intégration des pales, l'intégration du shelter électrique sur le port. Donc on a une zone, on a une discussion régulière avec le port de Normandie.
So we're currently in a discussion with the ports of Normandy for using a zone of 1.5 hectares.
Avec un plan d'intégration de nos sur ces 1,5 hectares de nos turbines, de nos 7 turbines, cette fondation et des lestes prêts à être envoyés en mer.
So the purpose of the site is to get things ready, so they're ready to send out to the site for installation.
C'est vraiment la localisation parfaite pour
The Ras Blanchard is the ideal location for these turbines.
Les durées de transit sont vraiment très faibles, on est très proche.
So we're quite close to the concession area from the port.
Donc là, on est bien avancé dans la phase de ferme pilote, qui est vraiment une étape intermédiaire du déploiement commercial. On commence aussi, on est bien implanté à Cherbourg, qui est vraiment le lieu idéal.
So we're already well established in Cherbourg.
Et pour déployer les turbines hors Blanchard. Et sur la supply chain, ce qui reste à faire, ce qui est encore ouvert, c'est 40% de la valeur sur la partie turbine fondation.
There's about 40% of the supply chain to be selected for turbine foundation, etc. Thank you very much.
Merci beaucoup, Raphaël.
Thank you, Raphael. We'll finish this. We'll come back to Brittany. Marlene Kiernovsky will present the site at Paimpol-Bréhat in the north of Brittany. Marlene is going to present us the expectations and challenges for this Paimpol-Bréhat site. I'm going to change the perspective slightly here because I'm not going to talk about technology. Our site and our role is about accompanying technologies in their development at our site in Brittany. Paimpol-Bréhat is a test site which was envisaged by EDF, Electricité de France, several years ago.
ont choisi de mettre à disposition les investissements colossaux qui ont été faits au service de la filière pour que d'autres...
So EDF is the owner of the site, but it's made these resources available to the tidal energy industry at the Pampelbrea site.
Qui est situé dans les Côtes d'Armor, à 6 km de Bréa, qui est plus un site d'essai de par sa ressource énergétique.
The site is located about 6 kilometers from the island of Brea.
Pour le test des turbines, mais qui vraisemblablement ne permettra pas des productions d'énergie très conséquentes.
And it's a site that has a significant potential for producing energy, tidal energy.
Donc, voilà, on lui reconnaît des caractéristiques de site de test.
The main characteristics of the site.
J'ai déjà un petit peu introduit sur les capacités ou l'environnement du site, donc des hauteurs de vagues significatives assez importantes, un marnage de 10 à 12 mètres, avec des situations exceptionnelles jusqu'à 16 mètres, des vitesses de courant qui vont s'échouer.
So it's a site that has significant tidal ranges, significant wave heights, and a water depth between 35 and 40 meters.
De travail qui sont relativement réduites, comme ça a été évoqué, un sol plutôt rocheux et une activité de geofouling assez intense qui permet aussi de tester la robustesse des machines.
So it provides the conditions for good test facilities for new turbines.
L'infrastructure d'ailleurs qui est en cours d'évolution, je vous en parlerai sur la partie besoin en termes de chaîne. Donc aujourd'hui, comme j'ai dit, le site est propriété de EDF.
So today the site still belongs to EDF.
Seanergy, on est un site de test en milieu estuarien à Bordeaux et on s'est rapproché d'EDF pour...
Seanergy originally had a test site in Bordeaux, a river site in Bordeaux, and has built a partnership with EDF at the Pampelbrea site in order to evolve its turbine development.
Autour de ces trois partenaires, on greffe les partenaires habituels que sont l'administration, donc la DPTM des Côtes d'Armor, et puis tous les acteurs de l'environnement qui sont regroupés dans les comités de suivi environnementaux et qui regardent de près tout ce qui se passe sur site.
So the site brings together a partnership of public sector, Electricity de France and Seanergy with the state planning authorities and environmental monitoring authorities to monitor the impact of the turbines.
Donc cette organisation, demain, elle devient une structure juridique à part entière, elle devient une fondation qui prend une ampleur tout à fait différente.
The structure is currently being formalised into an association.
De l'ensemble des technologies UMR en France. Donc, au-delà d'EDF à Paimpol, on va avoir le site qui est aujourd'hui piloté par Ifremer à Sainte-Anne-Cordy, le site du SEMREV à
federating it with a number of other sites in France with significant potential as well at Sainte-Anne-de-Porzic.
Le site de Mistral, qui est un site à construire qui est porté par la société Valéco. L'idée, c'est de mettre tout ce petit monde ensemble et toutes ces compétences dans un même groupe pour être plus fort dans la compagnie de la filière aussi.
So by creating this new association, we've got an opportunity to support the development of technologies with through a single body. So in terms of supply chain development,
alors peut-être déjà rappeler que aussi en tant que CPC, on a des besoins qui vont nécessiter des infrastructures logistiques et portuaires.
So port infrastructure obviously is a very important part of the installation deployment of tidal turbines. We can work with different ports, large ports like Brest, Cherbourg. Cable deployment, for example, needs good quality port facilities. Smaller port operations like Pampol, Les Ardrières are also important to us as well.
essentiel des activités qu'on a besoin de mener sur site et que je vais décrire dans cette slide. Donc nous, qu'est-ce qu'on fait concrètement? Quelle est la nature des activités qu'on est susceptible de sous-traiter?
So what are the types of activities that we are subcontracting?
L'objectif du site d'essai, c'est de pouvoir capitaliser sur les connaissances acquises en termes environnementaux. Donc on va faire sur les bathymétriques, on va faire de l'imagerie, on va faire de plus en plus d'acoustique sous-marine, de l'analyse.
So a number of important activities are ongoing at the test site where we need supply chain environmental monitoring of the site and of the and testing, geographical surveys, acoustic surveys, metocean current surveys, benthos and water quality surveys are all necessary.
Notre type d'activité qui est plutôt sur les sujets électriques, c'est l'entretien du poste de livraison.
We have an onshore substation which needs maintenance and testing. There's classic maintenance, of course.
Ponctuellement, on a pu mener des surveys du câble. C'est un câble qui est un peu particulier, c'est un câble qui fait 17 km, 15 km en mer.
The subsea cable is 17 meters long, 17 miles long, so it's significant.
Et qui a été suivi par des plongées d'observation. Il y a, je crois, 120 mètres de béton qui sont présents pour le tester. Donc, une surveillance annuelle pendant un certain temps.
When a cable requires surveying activities, maintenance, monitoring activities to check that it's continuing to function safely.
Sur un marché qui est déjà contractualisé aujourd'hui, depuis assez récemment d'ailleurs, mais pour vous donner un peu une idée du type de gros travaux qu'on peut être amené à faire ponctuellement, c'est-à-dire pas tous les ans, mais peut-être sur une échelle de 5 donc très fort sur la partie navire et plongée.
We have specific needs around vessels and divers. So lighter multi-purpose vessels, for example. We're always in the market for vessels for able to do smaller operations. Vessels which can be between 12 to 25 meters, lifting capacity from half a ton to 1 ton. Vessels that can support diving, diving activities around the turbine facilities. Important for vessel owners in the supply chain to understand that we will require certificates, registration, navigation permits, insurance, diplomas, etc. Demonstrate a certain level of competence. We do the same for divers as well.
Des débats assez sympathiques avec les sous-traitants. Plongée autonome autorisée exceptionnellement quand il n'y a pas besoin de faire des manipulations sous-marines conformément à la réglementation. Et puis on voit bien que dans le futur on va se tourner de plus en plus vers les ROV et les drones, même si jusqu'à présent la partie financière ne nous a pas vraiment permis d'aller très largement vers ces solutions, mais on va doucement un petit mot sur la partie environnementale, sur laquelle on est peut-être moins autonome que sur d'autres sujets de caractéristiques physiques.
Just a word on the environmental services that we need.
Pour toute la partie qualité de l'eau, Dantos, analyse.
Water analysis, water quality is an important issue which we need support on.
Dans les prochains mois, puisqu'on souhaiterait travailler sur un nouvel état initial du site du point de vue biodiversité.
We're going to be looking in the next few months to work on a new biodiversity survey of the site,
Et puis un petit mot sur les collaborations,
which will be the subject of a future call for tenders. We are also open to academic collaborations, currently working
d'une aide précieuse dans ces filières en développement. Donc on est très ouvert à une collaboration avec les universités. Le projet Tiger nous en a donné deux collaborations aussi. Donc avec
the Interreg Tiger project has given us the opportunity to work with 2 universities already.
en milieu marin et l'autre avec l'université d'Autan.
We work with the University of Normandy on aging of structures and ultrasonic non-destructive testing, and with the University of Caen in Normandy on flow and turbulence in the tidal sites.
Comme d'autres, on est et qui on sera de plus en plus dans le cadre de la fondation soumis à des procédures de marché public.
Like the other sites, we're required to follow the procurement rules. So if you're interested in working with us, get in touch. We can provide you further information on upcoming calls for proposals, calls for tenders. Thank you.
Les synergies et coopération et collaboration entre turbiniers, parce qu'on me pose souvent la question, voilà, dans le cadre de Tiger, de la situation.
So what is the cooperation between the different tidal site developers in the Tiger project?
Accompagner la baisse de coûts, la montée en régime de l'industrie. Donc, slide d'après, globalement, enfin, sur tout ce qui se passe dans le
Knowledge around reducing costs is obviously critical.
les synergies sont vraiment compliquées. On est chacun responsable de notre design.
We're each responsible for design.
De conceptions qui sont différents.
Obviously delivering our own individual business plans.
Le cœur de valeur des turbiniers, les synergies possibles.
Synergies that are possible.
Voilà, c'est pas quelque chose qui est pertinent. Voilà, de développer. Il y a peut-être à terme, il y aura des briques technologiques où les fournisseurs nous diront on n'est pas loin et d'essayer de faire ça comme ça se fait sur l'éolien pour des couronnes d'orientation de bio ou des choses comme ça, mais là on est pas là pour le moment. Donc les principaux champs de collaboration,
The main areas for collaboration,
et sur lesquels on commence à discuter,
so upon which we are discussing
de plus en plus,
more and more, are things like resource and meta-ocean assessments.
On a le deuxième autre point, c'est surtout ce qui est permitting.
We've got a lot of discussion ongoing between the sites and the developers around consenting.
Où là aussi, on a des synergies aussi. Très rapidement sur la ressource.
So if we look a bit more detail at resource and meta-ocean assessment,
Il y a des tâches qui sont possibles. Le but est de commencer à discuter sur la mutualisation de campagne, comme c'est dans le cas de Tiger, où sur le site du Rat-Blanchard, on a fait une campagne de pose d'ADCP en collaboration avec Normandie Brunette. Et puis après, sur l'analyse et l'interprétation et aussi la construction et l'évolution des normes qui servent au design.
So yeah, we've worked closely together with Normandy Ardulien on the deployment of ADCPs to get feedback information. With consenting, there's common topics between us, such as environmental studies, environmental follow-up. So sharing experience.
Et la dernière slide sur le raccordement interturbine et la connexion.
So in relation to connection, grid connection for the turbines, common topics, output power, control monitoring, discussions around export voltage.
Est-ce que vous avez des questions sur sur les sujets qui ont été présentés?
Welcome any questions from anyone about anything you've heard this morning.
Question to each turbine developer, really. When you're looking to the supply chain for support, what are the main areas of innovation that you're looking for your designs? If you could just give us a couple of examples, that'd be great.
On va chercher des briques techno qui ont été RL d'au moins 7 pour ensuite les adapter à notre système avec un déploiement de qualif. Mais en aucun cas, dans nos choix de conception, on va chercher des innovations sur des briques technologiques.
In fact, what we want to do is focus on quality and making bulletproof bits of kit. The innovation hasn't been done, but it's 90% done by us. We've got to take responsibility for the design, with the design authority, and getting the supply chain engaged early so they understand the design, the logic. They then they help us in terms of, is that manufacturable? Can it live up to the specifications? These sorts. We've learned to engage them early, not just expect them to supply what we want at last minute. But I agree with you. We're not looking for any particular innovation from them.
Chez Sabella, d'aller gratter un petit peu des usages et les adapter justement aux tidal.
So Sabella's looking for innovation from other sectors that can be adapted to the tidal sector. Reduction of costs with the machines. Things like cooling. Interesting to see how these questions are dealt with in other sectors. No, we're not in the business of inventing wet mate connectors. We just want to see if we can adapt them to our particular situation.
Est-ce que vous avez quantifié l'écart entre les performances, de coût et ce que ça pourrait générer? Et aussi, est-ce que vous avez quantifié tout ce qui va être plutôt de l'ordre des probabilités?
Have you quantified the gap between performance potential and cost?
You've hit an absolute key topic, which is, do you go fixed pitch, no gearboxes? There's an obvious reliability improvement from that. But then you don't generate as much. So it's the balance. And it comes down to the site. For example, our first machines were fixed pitch, and they still have applicability depending on where you are in the world and the regime of the site. So the site was done in Japan, very low wave environments, so the loads you're designing for, you could go fixed pitch. Major site, 16 to 20 metre waves, a fixed pitch turbine, just fixed pitch is not going to survive there without being incredibly expensive. So you need some form of release shedding load. Now that doesn't necessarily have to be a fully active pitch system. There's a whole bunch of decisions you can make around that. But in terms of cost of energy reduction, both of them have their merits.
Nous, on est convaincus qu'à partir d'une certaine taille de machine, le pitch est bien obligatoire. sans rentrer dans des dimensionnements qui sont juste débiles sur les génératrices. Donc on sait qu'on sera obligé de passer par là. Donc Tiger, c'est une opportunité de le mettre en œuvre et d'être en capacité de confronter ce design-là avec un design qui n'en a pas. On a un certain recul maintenant sur notre machine à Wesson. On a essayé d'implémenter des stratégies de contrôle qui nous permettent de nous affranchir d'un pitch variable en travaillant sur de la sous-vitesse notamment. On sait que ça a de l'intérêt, mais dès qu'on va taper sur des machines qui vont être autour du mégawatt, c'est des choses qui sont indispensables. Donc il faut être en capacité de pouvoir les appréhender et les questions que vous posez, elles sont évidemment au cœur des discussions qu'on a nous en interne et l'évaluation de nos concepts en dépend. Quoi.
Question for you, and I should know but I don't. The Open Sea get together, what are the overall benefits of that then, rather than those organisations staying sort of independent?
Donc on a eu de la très petite entreprise, c'est le cas de Seanergy, on a du très grand groupe.
So the group that we're creating brings together small, medium-sized entities, but also much larger groups like EDF. Everybody is challenged by their legal frameworks, individual legal frameworks. It's either too small to carry significant investments. Equally, when we're EDF, we just can't throw money at things, so finding this new structure, the right structure, which can be recognised as a research infrastructure at the European level, and can be reinforced by the added value of each of the organisations that make up the association. So by creating this association, it will be recognised as a public entity, something that happens in other European countries. But we are looking for us to create this similar sort of structure at the Paimpol Brea site. Because at the end of the day, we are bringing all these different skills and capabilities together. We're neither one or other. And our added value is in terms of being able to take an overview and develop the capacity of the tidal sector site.
Ça nous semblait avoir du sens. Et puis on avait déjà des collaborations régulières au travers de projets communs. Donc en fait, c'est simplement aller un petit cran plus loin que ce que nous faisions déjà ces dernières années.
And the structure is bringing collaboration, of course, with other projects.
Yeah, Kieran Frost from the Catapult. I was wondering which parts of the French supply chain do you think are the strongest, and which parts do you think, would you like to see more competition and could be improved?
Non, clairement, nous enfin, le cœur du système, ça reste les génératrices. Nous, on a fait un choix techno d'utiliser justement des génératrices synchrones pour ces questions aussi de refroidissement, de coller la carcasse
So clearly our
c'est un dispositif de refroidissement qui présente des valences. Donc nous, on aimerait bien voir effectivement des acteurs qui positionnent en France sur cette techno. On a de super partenaires qui sont en Italie.
Yeah, our supply chain is spread throughout France and Italy, but we would obviously like to have a stronger supply chain in France, closer to the sites we're installing. We know we have to go to the European level looking for suppliers where we can't find the capabilities locally.
Il y a des élèves spécifiques dans plusieurs choses. Il y a l'urgence, mais il y a aussi l'implication dans l'industrialisation et dans le design pour s'adapter à leur savoir-faire, à leur connaissance et à leur confort.
So the challenge always is to adapt knowledge and experience from other sectors that can be applied in the tidal energy sector locally in France.
The other thing I want to add is the gearbox on our machines is fairly specialist kit, and not currently available in the French supply chain. It's about the only thing we're not finding in France, which is not bad out of a full system. Otherwise, my answer is exactly the same for everyone.
Comment prévoyez-vous la suite de Tiger?
For 2010,
I think there already is a legacy. I think Tiger, because of its size and because of the professionalism of the developers, certainly in the UK, it stimulated UK government to provide an energy generation subsidy for tidal stream. So, and that stimulated investment. And I get a sense that there's a similar excitement in France now as well. So that's fantastic. That's exactly what we wanted to achieve. As you've heard from the developers, it's not about putting single devices in the water anymore. It's about building arrays and building up the size of array. So what we need to look at now is how do we support these developers in being able to do that. I'm a firm believer that there's still a degree of innovation required for arrays and for sort of faster installation techniques, probably more bespoke vessels that suit high tidal flows and can do those installations a lot quicker. So that's really what I'd like to see. I don't know if it's appropriate to mention it now or do I mention it at the end, that there is another one of these supply chain events next week in Southampton in the UK at Seawork. And Seawork is an offshore sort of construction vessel type event, conference and exhibition. So they normally have sort of jack-up vessels there, crew transfer vessels, you're free to go on board and explore. It's a really good interactive show and there'll be another one of these sessions there. So thank you very much, Helen, for convening this get together and for keeping the turbine developers and the site developers under control. But you can see the enthusiasm from everyone here today, which is excellent. We've all got a common interest in making tidal energy successful and recognise the need for renewable energy. So thank you very much indeed for your time, and thank you for the interpreters doing your amazing job, and for pressing the button on the slides. Thank you very much indeed. Much appreciated.